So let us start partial differential equations in this class. Okay. So like ordinary differential equation. Can you define anyone what is ordinary differential equation? The definition is very similar. If you know the definition of what is ordinary differential equation. Yes. What is ordinary differential equation? Yes. Here only the definition is there. Okay, an equation which involves dependent variable, independent variable, or derivative of dependent variable with respect to independent variable. That is actual definition for ordinary, right? Similarly, in the same way, here also, an equation which involves in dependent variables or independent variables. Similarly, derivative of dependent variable with respect to independent variable. Similarly, derivative of, instead of derivatives, we'll say it as partial derivatives here. Okay, so partial derivative of dependent variable with respect to independent variables. Okay, but here independent variables for ordinary differential equation will be only one. Okay, but here in partial derivatives, independent variables may be one or more than one. Correct. So that is the definition of partial derivative. Okay, if you differentiate a dependent variable with respect to many independent variables like x, y. Okay, x, y, something, a, b, c, something like that. Okay, so here order of a ordinary differential equation and order of a partial differential equation is also the same. Okay, if we observe these examples, dou z by dou x, what is dependent and independent variables here? We observe this example, dou z by dou x plus dou z by dou y equal to 0. What is dependent and what is independent? Yes? Lakshmi, can you tell?
Dou z is dependent variable. Dou x and dou y is independent variable.
No, you should not say dou. You have to say letters only. Z. Z is dependent. X and Y are independent. Yeah. So whenever you ask dependent and independent, they should not include the operator. Okay. Dou is an operator. Okay. You have to say Z is a dependent and X and Y are independent. Okay. So here X and Y are independent variables. And if it is like that, what will be the order? What is the order? Highest derivative which is appearing in the equation. Okay, can you tell the order of the differential equation here? Highest derivative is how much? First derivative or second derivative like that? We have only first order derivative here. So order is 1. What will be the degree?
1.
1, right? Power of highest derivative which is appearing in the equation. Similarly, homogeneous and non-homogeneous. So in the previous class itself, we have told what do we mean by homogeneous and non-homogeneous. Right hand side of the equation must be equal to 0. Okay, so that is called homogeneous. And non-homogeneous means some function of x and y should be there on the right hand side. Okay, so on the right hand side, we are having 0 here. So we call it as homogeneous differential equation. Okay, similarly, for the second one, okay, you observe the second one, what are the independent and dependent variables? Yes, Harshita, can you tell? In the second equation.
Yes, sir. Uh,
Hmm.
X and Y are independent and Z
Hmm.
is dependent.
Yes, what will be the order for this?
Second order.
Yes, because here second order derivative is there. One is with respect to x and one more is with respect to y. Okay, but the still order is 2. Okay, next degree.
One.
Degree is 1 because power of this equation is 1. Okay, power of this order derivative is 1. Similarly, whether it is homogeneous or non-homogeneous.
Non-homogeneous.
Because here right hand side function of x y is there. So in the that's why we have told it as homogeneous or non-homogeneous. So it is non-homogeneous. Similarly, if you observe the third equation, so what is the order of the differential equation?
So,
So order is 2 because here second order derivative with respect to x is there. Okay. Similarly, whether it is homogeneous or non-homogeneous. So just to confuse you, he has given a bit twist. Is it homogeneous or non-homogeneous? So here, dou square z by dou x square equal to dou z by dou y plus 2z is z. Okay. So what we need to do is we have to take all dependent variables and their derivative should be in the left hand side. So if you take dependent variables and their derivatives to the left hand side, what happens? Dou square z by dou x square plus minus dou z by dou y minus 2z is equal to 0. Now you can say it clearly, it is homogeneous equation. On the right hand side only functions of independent variables should be there. Okay, so on the right hand side 0 is there. So that's why it is called as homogeneous differential equations. Usually in GATE, this kind of questions will be asked. So you have to check whether it is homogeneous or non-homogeneous. So remember one thing, all the dependent variables and their derivatives must and should be in the left hand side. On the right hand side, if you find any function of independent variables, that is called non-homogeneous equation. Okay. Similarly, if you go for third one, fourth one, so whether it is, what is the order of that equation? Fourth equation. Order is?
Two.
Yes. And degree is?
One.
Similarly, it is homogeneous equation. Similarly, if you observe the fifth one, it is also of same kind. Okay, so now we'll go for formation of partial differential equation. So I think you have learned how to form uh, differential equation in ordinary differential equation. Correct. How you used to do? Suppose if you find any arbitrary constants, a comma b comma c. So if you find these arbitrary constants, we used to differentiate that many times. Correct. Here also we used to follow the same thing. Okay. Instead of arbitrary constants, here you may get arbitrary constants or arbitrary functions. Okay. Like in the previous classes, we have while integrating partial derivatives, we used to write some functions, right? F of y comma y, x comma y, or f of x comma z. We used to write like this, right? While defining in vector calculus. Okay, Lagrange's equation. In particularly while using Lagrange's equation, we used to write arbitrary functions like this, right? So, so these kind of functions also will get. So we have to eliminate all such kind of arbitrary constants and arbitrary functions from the equation, and we should be able to write the derivative of dependent variable with respect to independent variables. Okay, so in that way we'll find partial differential equations by eliminating arbitrary functions. Okay, so here we are having some notations, so I'll explain it and later we'll enter into the problems on formation of partial differential equation. Okay, in general, in partial differential equation, we have standard notations. P is equal to dou z by dou x. We have to understood that wherever you see the letter P, so you have to understood that it is a derivative of z with respect to x partially. Similarly, Q is equal to dou z by dou y. Similarly, R is the second derivative of z with respect to x. Similarly, S is equal to dou square z by dou x dou y, or dou square z by dou y dou z, dou x, where z is a function of x and y. Okay. Similarly, T is equal to second derivative of z with respect to y. Okay. Similarly, you can write P as zx. Okay, z suffix x. Similarly, you can write dou z by dou y as simply zy. Similarly, how can you write R? Second derivative. In shortcut, you can write it as z. Here 2 times derivative with respect to x is there, so you can write it as zxx. Okay. Similarly, how can you write s? With respect to x and with respect to y is there. How can you write?
ZXY.
Z suffix xy, or here this can also be written as zyx. Similarly, T, you can write it as z second derivative of z with respect to y. So you can write it as yy. Okay, so these notations you have to remember. P equal to dou z by dou x, Q is equal to dou z by dou y, R equal to dou square z by dou x square, S is equal to dou square z by dou x dou y, S is that, T is equal to dou square z by dou y square. Fine. So you have to remember all these 5 notations. So we'll go into the problems. Okay. So here they are asking form a partial differential equation by eliminating arbitrary constants. So that means in this equation we need to eliminate A and B. Okay, so let us see how to eliminate this and how to rewrite this equation in terms of partial differential equation. So what do you mean by this Z? If you are forming this, means this is the solution of partial differential equation. So he has given the solution and asking us to form the differential equation based on the solution. Okay, so here Z is equal to this much is nothing but solution of partial differential equation. So he is asking in reverse way. Okay, so let us see how to form differential equation for this. So here he has given Z is equal to xy plus y into root of x square minus a square plus b. Okay, implies differentiate, take this as equation 1 with respect to x, okay, partially. Okay, if I differentiate on both sides with respect to x partially, what will get? Dou z by dou x in the left hand side is equal to dou by dou x of xy plus dou by dou x of y into root of x square minus a square. Similarly, plus dou by dou x of b. So can anyone tell? Dou z by dou x is equal to differentiation of xy with respect to x partially.
Y.
So we'll get y plus here y is outside. So differentiation of root x. How much?
One by two root x.
1 by 2 root x square minus a square. Okay, into we need to differentiate x square minus a square with respect to x. So I'll get 2x plus differentiation of b with respect to x. It is 0. Okay, so finally dou z by dou x is equal to how much? Y plus 2xy. So here 2 to get cancelled. You can write finally xy divided by root of x square minus a square. Fine. So take this as equation 2. Now again what I will do is we have differentiated for one time. Since here arbitrary constants are 2, so we need to differentiate equation 1 for second time also. So this time what I will do is instead of differentiating equation 2, I will differentiate equation 1 with respect to y. Instead of doing the same with respect to same variable, I will do with different variable. So that means differentiate equation 1 with respect to y partially. Okay, so you can differentiate the same equation, that means equation 2 one more time. So then also you can eliminate it, but it will be difficult to eliminate a and b from this. So that's why what I am doing is I will differentiate this one with respect to y this time and we'll check. Okay, so dou z by dou y is equal to dou by dou y of xy plus here dou by dou y of y into root of x square minus a square plus dou by dou y of b. So dou z by dou y is equal to differentiate xy with respect to with respect to y. How much will it?
X.
So we'll get x plus So here y
Root of
is
x square.
x square minus a square into 1 plus 0. Correct. We'll get this much. So now write this is equation as equation 3, or you can rewrite this equation 2 as dou z by dou x value. I have defined it as p. So p is equal to y plus xy divided by root of x square minus a square. Correct. Similarly, I can write this as q is equal to x plus root of x square minus a square. Okay. So now from equation 3, I can write this as equation 3. What will be the value of root of x square minus a square? What is this value? This is nothing but q minus x. Correct. So I have sent this x to left hand side so that we got root of x square minus a square value is q minus x. Okay. So substitute this value in equation 2. You can write this as equation 2. Implies from equation 2 we got p is equal to y plus xy divided by root of x square minus a square. We got it as q minus x. Okay. So finally we have eliminated a and b. Correct. So we can write this as, you can simplify this and also you can write. So what happens if you simplify? Send this p to left hand side, we'll get p minus y. Okay, so p minus y equal to xy by q minus x. You can send this q minus x also left hand side, so that q minus x is equal to xy. So either you can write the solution as this much, or you can write the equation as this much. Okay, so here where p is nothing but what? Dou z by dou x minus y. Here q is nothing but dou z by dou y minus x is equal to x1. Okay, so among these three, you can write any one, no problem. You can end the solution with any three of these equations. Fine. So what we did, finally we have eliminated a and b, and we have written the equation in terms of derivatives of z. Clear? So just go through it once. So we need to find partial differential equation of family of all spheres whose center lie on the plane z equal to 0. Okay, and have the constant radius r. Okay, so if you want to know this, first we need to find what is the family of all spheres with centers. Okay, so what is the family of spheres? Equation of a sphere. If you remember the concepts of 3D geometry in PUC. Equation of sphere is what? It is nothing but x minus a whole square plus y minus b whole square plus z minus c whole square is equal to radius r square. Okay, where a comma b comma c is the center, comma r is radius. R is radius means constant we have to take, and we have to take A, B, C are arbitrary constants. Okay, so in this equation what is saying, all the spheres whose centers lie on the plane z equal to 0. So on z is equal to 0, what will be the radius of sphere? Sorry, what will be the centers of the sphere? So C will become 0 at that time. So implies given centers lie on plane z is equal to 0 implies C is equal to 0. Okay, so replace C equal to 0 in this equation. Your required equation, family of curves, is nothing but x minus a whole square plus y minus b whole square plus z square is equal to r square. Okay, so here r is constant. Okay, a and b are arbitrary constants, and z is a function of x bar. Okay, so these points we have to remember. Okay, so here we have to take a and b are arbitrary constants, and we are going to eliminate only a and b, not r. So how many times we need to differentiate this equation?
2.
So 2 times we need to differentiate this equation. So therefore, differentiate, take this as equation 1. Equation 1 with respect to x partially. If you differentiate this one with respect to partially, with respect to x partially, so what will be the differentiation of this equation with respect to x?
Two into x minus a
2 into x minus a
plus 0,
plus 0 plus
0.
no. This is function of x,
Dou,
right?
dou z by,
Dou z,
yeah,
dou z by dou x is equal to right hand side 0.
0.
Yes. So you can write this one as 2, you can take common and you can send that side, so that will be 0. Now x minus a you can keep in the left hand side, which is equal to minus z dou z by dou x, or you can write this one also as x minus a is equal to minus z, instead of dou z by dou x you can write it as t. Okay, you can take this equation as 2. Okay, similarly differentiate equation 1 with respect to y partially. What happens? Yes.
0 plus
0 plus 2 into y minus b s plus 2z dou z by dou y is equal to 0. So you can write y minus b is equal to minus z dou z by dou y. Or you can write this one also as minus b is equal to minus z dou z by dou y. Can we write it as?
Q.
It is q. Fine. Yes. Next. Therefore, substituting this equation 2 and 3 in equation 1. Substitute equation 2 and 3 in equation 1. What happens? Minus zp whole square plus minus zq whole square plus z square is equal to r square. Implies you can take z square common, p square plus q square plus 1 is equal to r square. Okay, so this is the required equation which we need to find. It's a required partial differential equation for the given family of all spheres. So just go through it once. If you have any doubts, let me know. So solution. Given equation, what is there? You can write. Given z is equal to y square plus 2 into f of 1 by x plus log of y. Okay, implies first we'll differentiate this one with respect to x. Okay, so that means dou z by dou x. Okay, so you can write differentiate equation 1 with respect to x partial. Okay, take this as equation 1. So dou z by dou x is equal to how much?
Zero.
Yes, 0. Next plus 2 into differentiate f with respect to x. F dash of
F dash.
1 by x plus log y. Okay. Now into differentiate this one with respect to x. Inside 1 by x plus log y. So differentiation of log y is 0. Differentiation of 1 by x.
Minus 1 by x square.
Minus 1 by x square is it. So implies dou z by dou x, or you can write this one also as p is equal to 2 into minus 1 by x square. So I can write it as minus 2 by x square f dash of 1 by x plus log y. So take this as equation 2. Now differentiate equation 1 with respect to y partial. So what happens? Q is equal to, so if you differentiate with respect to x,
2y.
so with respect to y, so I'll get 2y plus
2f dash of
f dash of 1 by x plus log y into differentiation of 1 by x plus log y. with respect to y. How much?
1 by y.
So 1 by y. Okay. So q is equal to 2y plus 2 by y f dash of 1 by x plus log y. Now I'll take this 2y to left hand side. What happens? Q minus 2y is equal to 2 by y f dash of 1 by x plus log y. Okay, take this as equation 3. Observe equation 2 and 3. What if you do? We can eliminate f dash. We need to eliminate f, right? So observe equation 2 and 3. What operation if you do? We can eliminate this one, f. So if you divide on both sides, what happens? Equation 2 divided by equation 3 implies what happens? P divided by q minus 2y is equal to here minus 2 by x square f dash of 1 by x plus log y divided by 2 by y f dash of 1 by x plus log. Have divided equation 2 by equation 3. So f get cancelled. So 2 also get cancelled. What will be the final equation? P by q minus 2y is equal to, so this x square will remain in denominator and this y will go to numerator. So minus y by x square will get. If you do the cross multiplication, you will get px square is equal to minus y into q minus 2y. You can send this to left hand side. So px square plus y into q minus 2y is equal to 0. Or we can write this as px square plus qy minus 2y square is equal to 0. Or you can write this one also as is equal to 2y square. Okay, so this is actual partial differential equation which you need to find.